Okay, people, this will be a quick overview of density and then also the assignment that will go along with this, or actually it's assigned in Thursday of Google Classroom for this week. So density is another of those physical properties that we've been talking about, and each material that you can think of has its own amount of density. So the definition of density itself, yes, you should write this in your notebook, is simply the amount of mass per unit volume. So, and that's the fancy science way of saying it. The other way to think about it is how much stuff there is in a certain amount of space. So hopefully you're familiar with marshmallows, and I want you to imagine a regular marshmallow and imagine holding that in your palm. It's not going to have that much weight, or it's not going to have that much mass. We put that on a scale and it will weigh, or it will have a mass of maybe half a gram, maybe. Now, I don't know if you've ever held a chunk of lead or copper, but I want you to imagine a chunk of one of these metals that's the same exact size as that marshmallow. It's going to have a lot more mass. It could probably weigh up to 30 grams. So you have a half a gram for this marshmallow, or you have 30 grams. So that's a huge difference. They occupy the same amount of space, they have the same amount of volume, okay? But the metals have way more material, way more matter packed into the same amount of space, so it is much more dense. So again, even though they take up the same amount of space, the metals have a much higher density than obviously a marshmallow would. Now, even within metals, you will have some that are denser or less dense, and in your hand they will feel heavier or very light, and I have some examples of this in my classroom. So to calculate density, you simply need to know the mass in grams and then the volume in cubic centimeters. You could also use milliliters if we're finding the density of a liquid. That would also work. But for simplicity here, I kept the labels with cubic centimeters since we're working with solids. So if we're working with a marshmallow, the mass of that marshmallow, I'm just plugging these numbers in, would be 0.5 grams. To find the density, I divide that by its volume, which is 8 centimeters cubed. This comes out to a pretty tiny amount, 0.063 grams per cubic centimeter. Okay, so for every little cubic centimeter, right, which is maybe the size of the end of your pinky, okay, there's only 0.063 grams of matter in there. Compare that to an equal sized chunk of metal, and one of these weighs or has a mass of 24 grams, okay, but it has the same volume. See, the number in the denominator here is the volume. It's the same exact size. So the chunk of metal over here has a density of 3 grams for every cubic centimeter that you're dealing with. So that's, I don't even know how many times greater. 3 grams versus 0.063. So way more matter over here in these very dense metals. Now I have this density, I usually call this the density triangle. So to use this, you cover up the one you want to know. So if you want to know density, you cover that up and you're left with mass divided by volume. That's why they're situated how they are. You see that same equation over here. And you'll see this in a little bit on your other assignment. If I need to know the mass, I just cover that up and I'm left with density times volume. And your label will still be grams. If I need to know volume, cover up the volume and I'm left with mass divided by density. Okay, so that's a quick overview. We're going to do some calculations in our assignment. And so let's get out of this and move over to this. So this is in Google Classroom, or will be by the time you see this. Again, a quick overview. We have several units of density that we could use. It could be grams per cubic centimeter, grams per milliliter if we're working with liquid, kilograms per meters cubed. We're going to stick with this first one, but all of these are examples that you may see. Okay? Here's a reminder of what mass is. You have to measure that using a triple beam balance or a scale. If it's a liquid, you would need to know the mass of the container first so you can subtract it from the total. Let's say you're putting liquid into a beaker, you need to know the mass of that beaker when it's empty so you can subtract that mass before you find the mass of the beaker and the liquid together. Volume has been our topic the last couple days, so this is just a reminder. Here are all those equations. If I need mass, okay, I'm left with density times volume. If I need volume, I'm left with mass over density, okay? Quick facts here. If an object's density is less than 1 gram per cubic centimeter, it will float. That's why marshmallows float until you soak them, right? And then they might sink a little bit. But the density of water is exactly 1, okay? So this means if something has a density of less than 1, it will float. Think of some objects that you know of that float in water. They must have a density of less than 1. I also need to fix that label. I will do that soon. If an object's density is greater than 1, then it definitely will sink. So all of those metals we saw, they would sink if you just had a chunk of it. Okay, so this is going to give you some practice. You can tune into the Zoom and I will go through a couple of these in class at some point. So in here you're going to fill in the formula that you need and then you'll do the math. So yes, I want you to use a calculator. So I have mass for our first object. I have mass, I have volume, I need the density. Come back up here, what's my formula? Density is mass divided by volume. So that's what you'll type in here. D equals M over V, or divided by V. Backslash works just as well. Remember, I'm not going to type in here because that will ruin it a little bit for you guys. You'll calculate your density, so 12 divided by 0.5, I punch that into my calculator, it's going to come out to 24 grams per cubic centimeter. So everything in this column is going to have this same label. Everything in this column of volume is going to have this same label. Everything in the mass column is going to have the same label of grams. Capiche? So if my density is 24 grams per cubic centimeter, is that greater than 1? I hope you know that 24 is greater than 1. This will definitely sink, so you're going to put an X in the sink box. You will only have an X in either this or that, not both. Okay? If you need to, you can round to the nearest hundredths place. And that's about it. You have, I think, 10 of them on there. Okay, so if you have questions, please email me. I also have another video with some layered liquids by Steve Spangler. That's also in Google Classroom, so you can give that a look as well. Thanks for tuning in, and we'll see you later.